Hello viewers, welcome to my YouTube channel. We have an interesting question today that requires us to use the method of mesh analysis, that is electrical and electronics principles 1. So for this question, we just have to understand how to use mesh analysis. The meaning of mesh, in this case, actually we just have three of them. We have this mesh, we have that mesh, and we have that one. So you just need to assign the specific current to each and every mesh, meaning that I'll say this has to be, I'll move in that direction, I'll take this to be my mesh A, then I'll also move in that direction, I'll take this to be my mesh B, having that current, and this one having IC. Wow. So what are we supposed to do next? We just need to understand that if you take in this direction, the current which is going to pass through this has to be IA. The current passing through this is going to be made up of two currents. Whenever I'm in the first mesh, I'll take this current to be the driving current. Then that one is going to be the opposing current. Same applies to this. Then for this, we are going to have IB as the current passing through that. For that, we are going to have IC. And actually, for this, we are going to have two currents as well, which is going to be IB and IC. So whenever I'm in this mesh, we just need to understand that we are going to have IA minus IB whenever I'm dealing with this. For this, we have to be using IA minus IC if I'm in the first mesh. Same applies to the remaining ones. So what actually are we supposed to do for us to get all the currents like I6, I2, I1, and the remaining ones? We just need to use a simple understanding of coming up with three different equations. Then we are going to solve those equations using a 3 by 3 matrix, and we are going to get the total currents. Let's start, and we need to understand fully how we're supposed to do this. So I'll start with the first mesh. If you start with the first mesh, you need to understand that we are going to be using Kirchhoff's law here, specifically KVL, Kirchhoff's voltage law. So the voltage across this, if I'm using that current, it has to be negative. The voltage for this has to be positive. The voltage for this has to be negative, and the voltage for this has to be negative as well. So there we are going to have that we're going to have positive minus, we're going to have positive minus. Why are we putting this things like this? It's because the current produced by this will move towards the positive, meaning that here it will also have a positive terminal. It approaches the first part as the positive, or even on this. Same applies to the remaining ones. That's what we always do, meaning that here we are going to have positive minus, we're going to have positive minus, just like that. Even this must have positive minus. So check the other question that I just solved, or the introduction to Kirchhoff's laws, how you understand these things. Let's start with the first mesh. Okay, so I'll say mesh 1 or mesh A. Apply KVL in mesh A. So actually in the first mesh we have this, that, and that one. So I'll start with this one. We also have this. So if you try to count the number of elements, we have this, we have that, we have this, we have that, and that one. So all what you need to do in this case has to be something like this. In the first mesh, if you want to come up with an equation using KVL, or say V1 plus V2 plus V3 plus V4 plus V5 equal to 0, because according to KVL, we are saying the summation of voltage in a closed loop has to be equal to 0. All right, so how many voltages do you have? Remember, we are transversing in the same direction as current based on this, meaning that this is going to have a positive, that will have negatives. And if I come on this one, I'm moving in the opposite direction to the current which is being produced by that given voltage source, because the positive terminal, that's where the current is being produced to. So V1 has to be 100, V2 has to be minus because of this, then the remaining will just be minus as well. V1 has to be positive minus V2 minus V3 minus V4 minus V5 equal to 0. Remember, according to Now, Ohm's law, we know that voltage is equal to current multiplied by the resistor. Resistance has to be whatever you have, like this one. Then what current is it that passes through that same resistor? So like for this one, we are going to have two currents. Since we are in the first loop, or rather mesh, we are going to understand that this has to be positive, but we also have the other current which is opposing, meaning that this, based on the voltage across this, has to be what? Has to be having Ia minus the current which is opposing, in this case is IB, if I'm standing in the first mesh. When I come to this one, I'll take this to be a positive current, then this guy is going to be opposing. Simple as that. Same applies to the remaining ones. We are going to be doing likewise. So V1 has to be 100, V2 has to be 20, which is here because we are opposing. We are starting with the positive. There is voltage drop on that one because we are encountering the positive terminal first and the negative minus. So here V3 has to be the voltage across this. What is the voltage? We are going to have current multiplied by that. The current which is passing through this has to be I1 multiplied by the resistance. We are going to have 60 Ia minus V4. On V4 we have this. So here we are going to understand that the resistance has to be 30, but the current has to be Ia minus this one because we are using this mesh. So Ia is moving in that direction, then this one is trying to oppose. Hence we are going to have Ia minus IC. Okay, minus for this one we need to follow that, which is 40. Open. Then the currents that we have are supposed to be Ia minus IB equal to 0. Okay, so let me try to finish this, come up with the first equation. So we are going to have 80 minus 60 Ia minus 30, open, Ia minus IC minus 40 Ia minus IB equal to 0. So do simple mathematics on this part, making things in a proper order. If we try to do some simple mathematics, we are going to understand that this, that, and that, we are supposed to get 130 Ia, then the remaining ones are supposed to be minus 40 IB minus 30 IC equal to 80, and this has to be equation number 1. Also say apply KVL in mesh B. So we are coming to the second mesh, which is this one. Remember, if I'm using this one, I have a certain number of elements as well, which is this 50 volts, that one, that one, that one, and that one. We have 1, 2, 3, 4, 5 as well. So we are going to do the same stuff, but you have to be careful because if I'm transversing or moving in that clockwise direction, this has to be positive because we are moving in the same direction as its current. Even this has to be positive because we are moving in the same direction as the current it produces. Then for this one, we are going to have the current as IB minus IA. For this one, we are going to have the current as IB minus IC. I think we understand what we are talking about. So I'll start with the voltages. 50 plus 20 minus I'll say 40, open, IB minus IA. This 40 we are talking about is the one on this given position. Then I'll say minus 40, open, IB minus IC minus 10 IB equal to 0. So doing simple mathematics, this is something which is very simple and straightforward. We are going to have minus 40 Ia, and this, that, it has to give us plus 90 IB and for IC it has to be minus 40 IC equal to what? Equal to 70, and this has to be our second equation. Let's try to do likewise to the last mesh. Let's say apply KVL in mesh C. Okay, in mesh C, we have to apply KVL as well. In mesh C, we have to apply KVL. The mesh we're talking about is the one we're able to see this part. So since we are in mesh C, this guy is going to have IC only. Then for this, must have IC minus IA. For that, must have IC minus IB if you are coming on the part of currents. So we are going to have, remember, we just have to put minus. Like for this one, since we are using this, the current or the voltage on this has to be negative, because it's more like we are dropping in the voltage, encountering the positive terminal first, coming to this. So this has to be negative 20 IC. Then you come to the remaining ones. Okay, so we're going to have negative 20 IC minus, we have 30 open IC minus IA minus 40 IC minus IB. The reason why we are putting minus for this is because the voltages across a resistor are supposed to be negative if you are moving in the same direction as current, according to Kirchhoff's laws. This, so putting this in a proper order, we are going to end up having something like this. Then minus 40 IB plus this, that, that. So we are going to have okay, so 50. Okay, and this has to be our third equation. Now the question is, how do you handle the same three equations? The calculator is going to give us a straightforward answer if we make a 3 by 3 matrix. How do you make the same 3 by 3 matrix? So we have 130 I A minus 40 IB 30 IC equal to 80 as the first equation, minus 40 IA plus 90 IB minus 40 IC equal to 70 as the second equation. And lastly, is 30 IA minus 40 IB plus 90 IC equal to 0. So if you check, we are almost making a 3 by 3 matrix. How do you make a 3 by 3 matrix? It has to come out as so we have 80, 70, 0, then we have 130 minus 40 minus 30 minus 40 90 minus 40 minus 30 minus 40, we have 90. So we are going to have IA. Simple. So we can punch this on the calculator and get IA, IB, IC direct. Okay, how do you punch this on the calculator? How do you punch this on the calculator? Okay, so how do you punch this on the calculator? Go on mode and go on 5 and go on 2. You find that it will give you a 3 by 3 matrix. So enter all these numbers until you reach on that given part. I'll say 130, you say equal to negative 40 equal to negative 30 equal to, and finally 80. Then it drops. It will give, you enter the second row. 90 minus 40, you enter your 70, you drop, you enter your 30, you enter your negative 40, you enter your 90, and we enter your 0, which is at the end. If you enter this, then what you're supposed to do is just say equal to. So I'm getting the first current as 1.63 amps. That's our first current. Equal to again, the second one is 2.176 amps. Wow. The other one is 1.511 amps. 1.511 amps as the third current. So you have to be very, very careful, because these are not the current we are looking for. These are not the actual currents we are looking for. So in this case, IA and I1, they are moving in the same direction, or the same I1 is the one which is equal to IA. So to simplify that, you say I1 is equal to IA, which is equal to what? 1.63 amps. You get that? You come to I6. I6 is just the same as IB, because IB is the one which is passing on this, which is just one and the same as that current. So you say I6 has to be equal to IB, 2.176 amps. I3 is just the same as IC, because it is the current which is passing on that resistor. So you say I3 is equal to IC, giving us 1.511 amps. Wow. If you proceed, you understand that here IL has to be equal to IL has to be equal to IB, sorry, IA minus IB. Okay, so I need to write on top here. Say IL has to be equal to IA minus IB, which is equal to 1.63 minus 2.176. You get your answer there. Then I5 has to be equal to what? I5 has to be equal to IB minus IC. So I5 has to be equal to IB minus IC, which is equal to 2.176 minus 1.511. You get your answer there. Finally, if we come to I4, I4 is equal to this has to be IA minus IC. So I4 has to be equal to IA minus IC. So I4 is equal to, what is IA? We know what IA is. IA is 1.63 minus 1.511. I4 has to be gotten, and you get your answer. Yeah. So this is how we solve this question. Try to share with your friends. Don't forget to subscribe to our channel for more incoming videos. Thank you very much for your time.